We'll go ahead and just jump right in. Thanks for joining us and letting us have this conversation here talking about electric vehicle charging and grid infrastructure and the impacts thereof. My name is James Frazier and I'm with the Sacramento Municipal Utility District. Just to give everybody a little bit of background that may not know, we're a publicly owned municipal utility. We're governed by a board of 7 community elected board members. So they set all of our strategic directives and all of our priorities, and all the long-term vision that we're working towards is established by that community elected board. We serve about 1.5 million customers, and that accounts for about 625,000 individual accounts. To give a little bit more background on myself and what my role is at SMUD, I'm part of our energy strategy group, and so I specifically work on our forward-looking strategies, how we're thinking about technology disruption, the impact that it'll have on the grid, and how we're making sure that that impact is really in line with the way that we're planning and that the tactics that we're executing on today build into that long-term vision. So for this panel, I'm going to talk a little bit about how EV charging affects that forecast, the types of things that we're thinking about, and the way that we think infrastructure could be impacted by EV charging. Before I jump into that, I want to give a little bit of background on kind of what that high-level long-term vision is for SMUD, so kind of what the rules of the game are for us. At the end of 2018, so just recently, our board adopted a new strategic directive as part of our IRP process that established a net zero greenhouse gas emissions target for the Sacramento area for SMUD. And so that's an incredibly lofty goal. We're looking to do that by 2040, so actually 5 years in advance of California's SB 100 net zero or carbon-free retail energy for California. So we're definitely leaning forward in what we're trying to do with respect to greenhouse gases and the environmental impact for the community. One of the things that came about when we started having that conversation is that if we're not addressing greenhouse gases and we're not addressing carbon emissions at both the grid side of the problem, but also at the transportation side of the problem, then we're leaving a significant amount of those emissions on the table. So it immediately forced us to start thinking about what do we need to be doing with respect to decarbonizing transportation. And as an electrical utility, our main responsibility there is how do we provide infrastructure to enable all the charging that needs to happen? How do we make sure that we're putting clean energy into those vehicles so that you're not just replacing a gasoline engine with carbon emitting resources? So really making sure that we're looking at a comprehensive solution and designing something that's sustainable and durable long term.
When you think about the impact of electric vehicles and you're trying to get customers to adopt them, can you talk a little bit about how the utility thinks about the ways that they can get them to adopt them and what the barriers are?
Yeah, absolutely. And so when we think about electric vehicles, you think about kind of early adopters, and you've got your segment of customers that are very excited about the technology and they're very interested and they're ready to buy in. And now we see a lot more models kind of coming to the market, a lot more availability of electric vehicles, and all of a sudden it's a real car for a lot more people. Whereas before it was just kind of this leading technology, this might be a thing. So when we're looking at technology and electric vehicle adoption, we're thinking about how people are going to use that technology. And we look at DC fast chargers as being a type of gas station replacement, if you will. It helps alleviate range anxiety, but also when we think about EV charging, it's also your day-to-day living, right? How do we make sure that customers are comfortable going to the grocery store and charging their car and charging at home and have access to charging at their workplace? And how do we provide that complete charging solution to the customer that's going to help them find value in their transportation, but also find value in the way that we're providing energy to those customers? When we adopted this greenhouse gas target of net zero by 2040, along with that came a significant number of transitional points along that path. And from a strategy standpoint, we want to be thinking about those points. At some point in the curve, we're going to be doing all new sales of electric vehicles, or all new sales of vehicles are going to become all electric. We're going to start phasing out gas stations, and we're going to see higher and higher adoption rates of electric vehicles and more DC fast chargers. From a utility perspective, we do a lot of scenario analysis. We ask ourselves, what is that future environment going to look like, and how are people going to charge their cars? Are they going to start using DC fast chargers the same way that we traditionally use gas stations, or are they going to mainly rely on workplace charging, or will charging continue to be dominated by at-home charging? We also look at how that charging technology is advancing. And so as we're thinking about the charge rates of a DC fast charger, today when you go to a DC fast charger station, you're going to pull up, you're going to plug into a standard CCS handle or a CHAdeMO handle, and you're going to be charging at 50 kW. And that 50 kW charge rate is going to give you something on the order of 90 miles of range over the course of 30 to 35 minutes of charging. Well, today, when we design a DC fast charger station, when we provide infrastructure for that DC fast charger station, it's based on that 90-mile range at a 50 kW charger to support however many charge handles are there. But we're operating in an environment where technology is evolving very quickly. And as part of that evolution, we have to be very aware from a utility standpoint that in a year from now, that charging could be done at 150 kW. That charging could be done at 300 kW. The range of these vehicles is going to be increasing from 120 to 240 to 300 miles. And we're going to continue to approach this parity point with respect to DC charging, where it starts to get closer and closer to what a gasoline engine actually provides value for customers today. And so in order for customers to really truly take on adoption, they have to feel that it's a comparable solution. And so we want to create that feeling. At the same time, from a utility standpoint, we have to answer a very difficult question, which is what's the right amount of EV charging to infrastructure to invest in to both enable that adoption and also not overbuild that infrastructure.
And this is depicting the goals that that have to occur in order to get to your greenhouse gas reduction targets, right? And I see on there, I think it's 2035, you have to have 100% of EV sales in the light duty in SMUD. And that's a pretty audacious goal, and it requires a lot of power from the electrical provider to do that. So.
So today, SMUD, we have about just over 1 million vehicles in our territory today. We're at about a 2% penetration rate for electric vehicles, so we're still very early in the curve, but we are trying to grow that very quickly. It's actually a really good point that the goal is very aggressive to get to that point by 2035. And that's one of the areas that I really want to chime in and point out that this is not something that SMUD is trying to do on our own. This is part of the greater vision that's been laid out by the governor in California. It's part of the vision that the city of Sacramento has. It's part of the vision that we see coming out of the Air Resource Board and the Air Quality Management District. And so really it's going to take participation from all of those authorities, all of those bodies, all of those participants, in addition to technology developers and innovators and customers and the private sector to really get to that goal. One of the things that we're trying to do is help visualize that map and help the community understand what that map looks like and how we get to the destination. But it's going to take contribution and commitment from all of the stakeholders along the way to really make that possible.
So is SMUD, are you leading it? Or are you trying to facilitate it? Is that a better characterization?
So with respect to energy being an enabler for a significant amount of this effort, we are leading that energy enabling portion of the conversation. There are other elements of the conversation where we are participants and supporters. And so we're really trying to build on the momentum that's in place, and where there's not momentum, help our community find that momentum and create that momentum. And some of that's being done through pilots, some of it's being done through initial projects and demonstrations and education, but it really is entirely about the community more so than just the utility exclusively.
So 100% of light duty vehicles in less than, it's like 16 years basically. That's a lot of power. I mean, we're fond of saying, like, when two Teslas pull up to a Walmart to charge, they take more electricity demand than the entire Walmart. So when you think about providing the infrastructure for that number of vehicles, what are the infrastructure challenges, and do you invest and put infrastructure everywhere, or how do you think about it?
Yeah, so we really have to look at, and I like the fact that you're using power to describe that challenge, because in a lot of cases, especially with these early fast chargers, you're talking about low actual energy consumption, not a huge amount of kilowatt hours because the utilization isn't there. And so you may be getting 3, 4, 5 charge sessions in a day that create these massive spikes on the utility infrastructure. but don't actually result in a significant amount of kilowatt hour consumption. So it's low utilization of the grid infrastructure. If we fast forward kind of 10 years and we see the level of adoption that we're looking at and we have much higher utilization, it can turn that infrastructure into a very good investment, and because we're transacting a lot of kilowatt hours. But how do we facilitate that transition from where we are today into that future scenario is something that we look at quite a bit, and that's where we dive into different pilots and different control strategies to understand how we could limit that impact on the grid infrastructure. We think about it in terms of time of use rates so that we can make sure that we're providing the lowest cost energy to customers at times where it creates the lowest burden for the grid. And when customers are using that energy on peak, be it a coincident peak demand charge or an on-peak energy charge, that there's actually a price signal associated with the cost of operating that infrastructure. And that helps us not only collect the appropriate amount for the charging power and energy and infrastructure that's provided, but it also gives a signal back to the customers and the infrastructure operators around how we want them to use the technology and how it can be best integrated with the utility. So rates and pricing become a central element for how we start that conversation.
I think one of the fascinating things that you mentioned was that as rates go up, and so if you invest in infrastructure, that's going to go into the rate base, it can increase rates, and the people who are actually using the power that you need to drive adoption may then be less ready to use the power because they have to pay more. Right. And so you could have a vicious cycle where you don't get the adoption levels because you invest too much in infrastructure and the rates go up too high, sort of dampening the adoption.
Yeah, exactly. And so, like I say, when we're thinking about this, we run a lot of scenarios. We think about what the whole spectrum of future possibilities could be. And one of the things that we think about with DC fast chargers is, and we actually see this quite a bit today, is that a lot of the value from a DC fast charger is that it alleviates range anxiety. It doesn't actually result in a lot of cases in a massive utilization of that DC fast charger station, but it may be the difference between somebody saying, I know that station is close to my work. I know that if I don't get a full charge at work, that I can use that DC fast charger, and that's the thing that makes them comfortable buying an electric vehicle. What it doesn't mean is that they're going to drive their car to that DC fast charger station every single day and actually use it. And so from a utility perspective, we've made an investment in the infrastructure to support that station. That station is using capacity on the network. It's adding to our costs of operating the network. At the same time, that customer is then charging and using that electricity from the grid at home. They're using it from other places. But it's not a direct relationship to the infrastructure investment that we made. And so there's value there for both us and the customer, but how we assign that value, how we visualize that value, and how we make sure that we're making the proper level of investment to help alleviate that range anxiety, that's a very front of mind question. Because if we overbuild those stations and the utilization doesn't show up, that represents a significant cost risk on the infrastructure side for the utility.
Yeah, people always talk about range anxiety. I mean, I have an EV, and I'm not anxious about the range. I know what it is. It's charge anxiety, right? Where are the chargers? Are they available? And that's what most people, I think about when they think about buying an EV is like, can I charge this? And how do you make it easy for the consumer and reduce the anxiety related to charge?
Yeah, and that's a great point. And we actually have an example that goes on in our office with our car charging program at SMUD, where we see the adoption of electric vehicles and the participants in our charging program is very much related to the number of charge stations that are available. And so we're constantly looking forward at how much infrastructure do we need next year? How do we add more electric vehicles? How do we look forward to make sure that we're doing those things? We're going through a major remodel on our main facility building right now, and as part of that remodel, we're wiring and preparing to wire a significant number of the of the parking spots for electric vehicle charging. The follow-on question is, how soon do we actually install EVSEs in every single one of those locations? How soon do we make that final investment in the asset? And how do we make sure that once it's installed, it's actually going to get used, and not that we just over-install and electrify every single parking spot because it's even as the utility, it feels like the right thing to do. So it needs to make economic sense to invest in that infrastructure.
Right, so you're just like a customer. So
Yep.
FreeWire makes mobile applications, and SMUD has bought a few of our chargers. And actually at the booth yesterday, some SMUD employees were coming by, and they said, we want to test them on our vehicles. If I don't get into the parking lot before 8:30, I can't charge.
Yep.
And so our mobile units can be driven to those vehicles and charge those vehicles. The employees love it, right? Because they park their car, they go inside, the attendant drives the Mobi to the vehicle, plugs it in, they get a text that, hey, your charge is complete. And so they don't have to move their car, they don't have anxiety about, I'm in this meeting and I'm sitting on this, I'm basically tying up, I'm capturing this charge point. So it's a great it's a great product, and I'm so glad that SMUD is going to try them out in the community.
Yeah, it's a really clean fit, and the fact that I'm an EV driver at our organization makes it a personal convenience, actually. So kind of speaking from that standpoint, and especially because we're going through construction and remodeling, we're using a temporary parking lot, and so given that we have a shortage of electric vehicle charging and we're in a temporary parking lot, it doesn't make sense to spend capital and install infrastructure in that temporary parking lot when we know that that's not going to be the permanent location for that EV charging. And so the ability to actually have access to charging on a temporary basis until we have that final infrastructure in place, that creates a lot of value because, like I said, we're already at capacity on our EV charging. And so that's the thing that's going to help that next car actually start to charge. And that's one of the things that we're definitely excited about piloting and modeling out with the units that we have.
That's great, yeah, and you're only at 2% adoption, right? So as that adoption increases, there's a bunch of locations where construction is going on, or you don't own the facility, and you want to charge the vehicles. You need to charge the vehicles so people can get home, and so having flexibility really helps from an infrastructure planning standpoint.
Yeah, and with that 2% adoption, it's also important to keep in mind kind of what the adoption profile of customers and early adopters looks like. When you're talking about that first 2%, they're a lot more forgiving on nuance with the technology, availability of charging. They understand when they make the investment that they may have to go a couple miles out of their way to get their charge, or they may have to spend a little bit of extra time. But as you start down that path and go from 2% to 5% to 15%, the forgiveness of the customer continues to diminish, and the expectations continue to rise. And so from a utility standpoint, from a customer value standpoint, we really need to make sure that we're forward looking and that we are keeping up with those customer expectations and deploying charging infrastructure in a way that meets their value expectations. And so that's a very central element of the way that we think about these problems. The future is a spectrum of possibilities, and we consider a number of them. So this isn't an absolute, this is the right answer. This is just one of the scenarios that I find to be most interesting. What we're looking at, the green bars on this graph are the actual electric vehicle adoption or penetration rate in our territory. So on the leftmost side of the graph there, you can see where we're starting at that 2% number that we've been talking about. And then over time, we ramp up that number as we get closer and closer to our net zero greenhouse gas target in 2040. The orange line that you see moving from left to right is what the potential decommissioning of gas stations would look like over that same period of time. So as fewer and fewer people are using gas stations to fill their cars and fewer combustion vehicles on the road, there's less demand for those gas stations, and they become less prevalent. The availability of those gas stations as a function of the availability of EV charging is something that we've modeled in as having a potential influence on the adoption rates for electric vehicles. The blue line is the actual number of DC fast charger stations that we think we could need in order to drive adoption of electric vehicles. So this is to address range anxiety, this is to provide reasonable service, but in that blue line, we've modeled in where we are in the adoption curve. We've modeled in how many electric vehicles are in our territory, and we've modeled in the evolution of technology. So very early on, while we have a low number of DC fast chargers and a low number of electric vehicles, we're talking about 50 kilowatt DC fast chargers. And as we move forward in time, we have a couple of dominant terms in our equation, which are the EV penetration, so the number of adopters that we have, and then we have the actual vehicle range and the charge rate. So the charge rate helps the charge time come down, and it makes charging more efficient. But the EV charging and the EV adoption is the dominant term in the equation in the early years. And that means that for at least the next 20 years, next year we always need more DC fast chargers than the previous year. And if we continue to follow on that path, we'll have built infrastructure out to support, in this model, almost 500 DC fast charger stations. Now these are stations, gas charger equivalent, megawatt level, multi-handle stations. So about 500 of those across the territory. Well, if we continue to move that technology curve forward, in about 15 years, the first generation electric vehicles start retiring. They start being replaced with newer models of electric vehicles. Now the average charge time for electric vehicles is significantly faster, and the charger rate at those charge stations is significantly faster. Well, the need for all of those gas stations all of those DC fast charger stations starts to diminish. And what we find is that between 2040 and 2050 in this model, that number actually decreases because charging is so much better at these high-speed stations. And by 2050, we look at a possible number of 100 DC fast charger stations. What that means from a grid infrastructure standpoint, if we had built to that peak target and we ended in 2050 with the right number long term, we would have overbuilt 400 DC fast charger stations in the territory. And that represents cost, that represents rate increases for our customers, and it represents decisions that would have been made that weren't as far forward looking as we needed to. And so this scenario represents one of the things that we consider when we say, what's the right level of infrastructure? What are the research and development questions that we need to be asking today? And how do we make sure that we're making the right decisions and investments to spur the growth to hit our targets for EV adoption, but not overbuild infrastructure in a way that disadvantages our customers across the entire territory. And so it's a delicate balance. As a community utility, it's something that we think a lot about, and it drives a lot of our decision making.
That's really fascinating, because what FreeWire has done, we've heard the same things. You know, one of our investors is BP, British Petroleum. They own gas stations, and basically the idea is that fueling is up for grabs in the future, and how do you create a customer experience, and how do you scale your fueling operation? And so we built an integrated DC fast charger, so it's battery backed, and so it can take basically no infrastructure upgrade. It takes low voltage in, it builds up the high voltage in the battery, and it can discharge at 120 kilowatts. So that's an option for customers who want to deploy quickly and then can add on additional stations and follow that curve, basically. When you think about the customer experience and where those fast stations are going to be, fast chargers are going to be deployed, how do you think about the additional revenue opportunities that are available to consumers? I mean, because we think that people will use fast charging as a loss leader, that they will deploy fast charging. They may not charge a lot for the actual fast charging, but they want people into their convenience store. They want people using the car wash. They want people, buying their coffee. Right. How does SMUD think about that dynamic?
Yeah, so that certainly plays into it. So from our side, one of the things that we think a lot about is that we don't want to end up in a world where we have a significant number of stranded assets. So if there's not an effective business model for both the utility and the customer and the system operator and the EV driver, then that charge station is not going to be operating in that location for a long enough period of time to be meaningful. We want the technology investments and the infrastructure investments to be durable, and we want that technology to be there for the long term so that it's reliable for the customer.
To get to this infrastructure challenge, what FreeWire has done is it's made mobile power solutions, and the top two on the left are our product. One is SMUD branded, one of the units that SMUD is going to loan out to customers to bridge the gap between power needs at the grid edge and beyond the grid edge. The far left is showing the inside of the unit, and the DC fast charger I just mentioned is on the far right. We call it infrastructure light ultra fast charging, and these are all connected. And the idea that we think you've embraced and that we see from our customers is, how do I understand what it will cost me to deploy charging solutions for my employees, for my customers? How can I do that at a low cost? And how can I provide a driver-centric charge experience? And so people today, they want to park their cars, they want to click on a button and have the charge delivered, and this technology can basically do that for them. And what it does is it doesn't increase the utility infrastructure investment right off. It is very scalable, and that has this benefit, this virtuous cycle benefit of not raising utility rates, so that we can drive the adoption in at a high rate without a high cost. So, we're really excited to be working with SMUD, who's I think a visionary utility, and it's using these types of products, you can engage with your customer, you can help them take diesel generators off the market because these provide just mobile power, and you can start to reduce that charge anxiety and take power into locations that don't have power today, and where customers are sort of struggling, like how do I get my vehicle to the place I need it to go? The grid is pretty old, and it's constantly evolving, and it tends to evolve slower than customer demand. So maybe talk in closing just a little bit about the SMUD vision for how your products and services with respect to EV charging are going to evolve.
Yeah, so I guess the thing that I would add to that is that we took receipt of 3 of these units earlier this year. We have some very exciting pilots that are planned for these units. And that includes sharing out the EV charging units to the community to get their engagement and to get exposure to that technology. We're also looking at some further food truck opportunities to actually power some electric fleet opportunities that we have. And so with that, I would just encourage everyone to kind of keep looking at some announcements that we'll be having later this year about what those pilots are going to look like and the engagement that we have with them.
So you asked about how far the typical commute is for customers. I don't know what you see. We see when we do workplace charging that there's about 30 to 40 miles is what the EV drivers would like to get in order to get to work and get back. Do you see a different number?
So it's a little bit lower for us in Sacramento. But it's in that range, yeah. One thing to think about with respect to commute range and electric vehicles is that it's very weather dependent. If you're driving in the summer and traffic is slow and your commute is long and you're running the air conditioner, you're going to use a lot more energy per mile driven, and so that can matter quite a bit. I lived in Los Angeles for quite a while and had a 9-mile commute, and I would use about 30% of the range on my electric vehicle to go 9 miles. Terribly inefficient. But it was because I would run the air conditioner. So mileage-wise, about 8 miles each way, 16 miles daily trip. So from a charging management standpoint, that's something that we are actively working on within our research and development group. We're trying to understand what the price signals are, what the proper price signals are, what the responses that we can expect from customers are. Not anything on that side from a standard rate with respect to managed charging. It's all within the research and development side of the organization today. But we do expect that level of DER integration to be very important for actually long-term integrating the volume of electric vehicles that we're talking about.
Yeah, I think one thing on this point is that the drivers may not want to provide grid services. They probably just want to get a charge, and that's why integrating a battery between the battery, the car, and the grid creates an opportunity for utilities to have that capacity on the grid edge to do grid services while not affecting the driver's experience, and so that they get their charge and they get to work or wherever they're going.
The other part of your question was on the time of use rates. And right now we have on our residential rate, so in 2019, all of our customers are switching from a consumption-based rate to a time of day rate. So all of our residential customers are going through that transition basically in real time over the course of this year. And as part of that time of day rate, we have an EV charging window that if you have an electric vehicle, you can enroll in. And it's a 1.5 cent discount. I'm pretty sure 1.5 cent discount between the hours of 12 midnight and 6 a.m. So helping people understand how to set their charge timers and when they can get the lowest cost electricity that also lines up with our lower operating costs.
So what's the difference in those low rates to the high rates on the time of use? Is it significant, or do you know off the top of your head?
I would have to double check off the top of my head. I think it's about a 18-cent difference between on-peak and off-peak. Our EV charging rate overnight gets you down to about 9 cents per kilowatt hour, or 8.5 cents per kilowatt hour. So it's a really good rate relative to the price of electricity to charge your electric vehicle.
Absolutely.
Thank you.